Hi everyone, I am Ishtiaq and I will be discussing a design pattern named Facade Pattern. This is mainly based on Chapter 7 of the book Head First Design Patterns. The main idea is to combine together multiple subcomponents of a system into a simpler unified interface. Instead of dealing with the subcomponents separately, we will have an interface and some methods that will automatically deal with them for us. Let's look at a simple diagram to visualize the concept. Here we can see a system with 5 subcomponents. We need to initialize each of them and keep track of them. So we introduce a facade object. This facade object will handle all the different components for the client, while the client only has to deal with the simplified facade object. So when should we use the facade pattern? We should use this if we have a complex subsystem which contains lots of moving parts. We can use this to decouple the clients from the implementations of the subsystems. This will promote subsystem independence and portability. Suppose we want to integrate an app with a sophisticated toolbox or a library that has dozens of features, but we only need only a few of its most frequently used functionalities. We can use a facade to simplify accessing the toolbox. We can use this when we want to structure a subsystem into layers. In the previous slide, we saw 5 subcomponents. They themselves could be complex, and we might want to break them further down into more separate components. We can use new facade objects to control them. I will talk about these last two a bit more in the next slide. Here is a simple example. Suppose we want to upload short funny videos of cats. We could potentially use a professional video conversion library. However, this can have many different features and settings which could be overwhelming for a typical user. Perhaps the client only needs a simple method like encode video. This method will use some default values for all these features, and thus we have our first facade. Sorry. Here, we can actually break down the library into two layers, video and audio related layers. For each layer, we can create a facade and make a layered system. Let's look at a more detailed step-by-step example. This example is taken from the book. Suppose we want to set up a home theater system. This will have multiple different components. Let's look at them. We can have an amplifier, a DVD player, a CD player, and other components. Each of them will have their own different settings and features. For example, let's look at the DVD player on the right. This can have different settings. It can have pause, eject, play surround sound audio, etc. Let's look at the steps we have to go through to start playing or watching a movie. We can begin by turning on the popcorn popper. We can start the popcorn popper. We can dim the lights, then put the screen down, then turn the projector on, and so on. As you can see, there are a lot of steps here, and even just talking about them would take up a lot of time. You can see how this can overwhelm a user. They can become exhausted just by turning on the system and having to go through all those different steps and features. We can think of this system like a Java program. This will have different classes representing the components. For example, we can have a class representing the popcorn popper, and it can have a method for turning it on. Similarly, we can have classes and methods for the projector or the DVD player and the other components. As we saw, just turning the system on can be quite a hassle, but there are even more problems. For example, when the movie is over, how do we turn everything off? We will have to go through all the different settings and components in reverse again. Suppose I just want to listen to a CD or the radio. but I will have to set the features and settings for all the different components and go through all of them. Finally, if we decide to change our system, we're going to have to change the code to match our new procedure, and the client will have to learn this new procedure. Now, can we use the facade pattern here? This would actually be a very good setting to use the facade pattern because the facade pattern would help us greatly to deal with all the different subcomponents. Now, one thing we have to keep in mind is that there may be some tech-savvy users who might want to have access to all the different components and to all their detailed features. For such users, we should make sure that they can still access all the different subcomponents and tune them to their likings. Let's think about what main components we will have. First of all, we will need a facade class, which is like a simplified black box that will control all the different subcomponents for us. Secondly, we will have all the different subclasses representing the components like the DVD player or the lights. We will have to create objects inside the facade class for the different subclasses. Finally, we will have simplified methods that will deal with all the subcomponents. We will have a on method which will set some default settings for all the components and turn them on. We will similarly have an off method. Here we can see how the final simplified facade interface can be used. First, inside the main code, we will set up the components and instantiate them. Then we will instantiate our facade class with all the different components. Now, if we want to watch the film Raiders of the Lost Ark, we just pass the name of this film to the facade and call the facade's watch movie method. This will turn everything on and start playing the movie. When we are done watching the movie, we will simply call the end movie method and it will turn everything off, thus streamlining all the different steps. Let's look at what the facade home theater class might look like. The first step to creating a class like this is the composition. In the composition step, we will create instance variables to represent all the different subsystem components. The client will pass in reference to each of the components of the subsystem. Now, inside the constructor of the facade class, we will assign each of these components to their corresponding instance variables. Now we have to implement the simplified methods like the watch movie method or the end movie methods. Here at the top, you can see the watch movie method. This method will take in the name of the movie and it will set up all the different components and turn them on. It will turn on the popper, it will set it to pop, it will dim the light settings to 10. So basically, it will handle all the different components for us. And at the bottom, we have the end movie method, which we will use once we have finished watching the movie to turn everything off. We can see the class diagram for the facade pattern here. On the very upper left, we can see that the client class only has to deal with the facade interface. The facade interface will contain object references to all the different subcomponents and control them. The client never has to directly deal with the complex subsystem. Now let's pause the video for a moment and try to think about what are some of the advantages and disadvantages of using the facade pattern. Let's talk about the advantages first. It simplifies the use and understanding of a complex system by offering a clear and concise interface. Clients become less reliant on the internal workings of the underlying system. This gives us more flexibility with the subcomponents. We can easily change their implementations. We can remove particular ones or add new ones. The facade pattern can greatly help to create a layered architectural approach. This separation of concerns makes the system more modular and easier to maintain. Now let's see the disadvantages. Adding facade layer, sorry, adding an extra layer of indirection to the facade can introduce a slight performance overhead, especially this can especially be significant for performance critical operations. Applying the facade pattern to very simple systems can be overkill, adding unnecessary complexity where it's not needed. Setting up these layers and documenting them can be time consuming and a waste of resources. Adding facade layers in the system increases the level of abstraction. Because of this, the code may be more difficult to understand and debug. In conclusion, we are now familiar with a new design pattern. This can be quite a powerful tool. It can be applied in different situations and systems and can have multiple advantages. Nevertheless, as we discussed just right now, it can have multiple disadvantages as well. It may not be suitable or needed in a lot of simpler situations. So we should first think carefully about whether we actually need it in our particular project. On a similar note, as a person doing research on machine learning related topics, I could not resist the urge to share this final image. And that was my presentation. Thank you so much for listening. I hope I was able to give you an idea about the facade pattern. Goodbye.